Controlled Environment Plant Production Engineering Technology Education modules are developed and presented by The Ohio State University, Rutgers, the State University of New Jersey, and the University of Arizona, with support from USDA, NEFA, through their Higher Education Challenge Grant program. In this module, we'll discuss the topic of greenhouse maintenance. This module is presented by Dr. Peter Ling of The Ohio State University, Dr. A.J. Both of Rutgers, the State University of New Jersey, and Luke Power of The Ohio State University. This greenhouse maintenance module will allow you to meet 3 objectives. By the end of this module, you will be able to describe the benefits of investing in greenhouse maintenance, develop and use maintenance checklists, and determine who should perform maintenance. The first objective is to describe the benefits of investing in maintenance. Looking at the big picture, greenhouse maintenance includes taking care of the facility and structure and equipment. Maintained equipment fails less often and operates with greater efficiency and accuracy. Let's look at some examples on this and the next few slides. A clear filter is key to proper operation of an aspirated sensor. In fact, filters throughout the greenhouse need to be maintained for proper equipment operation. The efficiency of fan operation relies on belts that have integrity and are properly tensioned. Proper calibration and maintenance of seeding machines avoids missing rows of plants. As you can see here in the picture, there are several missing rows. Watering uniformity can be improved with better maintained irrigation systems. As you can see from the picture here, some of the pots are very wet and some are very dry. A 2% increase in heating system efficiency for a 30 by 100 foot greenhouse yields a savings of 285 therms of natural gas, 330 gallons of propane, or 200 gallons of fuel oil. Hire a qualified service technician. A 2% efficiency increase is possible with regular maintenance, which more than pays for the service. Objective 2 is to construct and use maintenance checklists. Routinely inspect equipment and systems using specialized inspection checklists. The recommendation for a routine check is at least once a month. In the checklist include preventative maintenance. This includes the performance of all regularly scheduled maintenance for each piece of equipment operated in the greenhouse. Good housekeeping practices should be integrated into preventative maintenance checklists. Work areas should be cleaned and floors kept free of debris. Integrated pest management practices, such as sanitation of equipment and surfaces, should also be included in a maintenance checklist. More about integrated pest management can be found in the Pest Management, Scouting, and Non-Chemical Pest Control Tools module. Safety equipment and devices should also be inspected for proper operation and use. In addition, there may be items specific to the local operation that must be considered on a maintenance checklist. When a maintenance inspection or attentive employee uncovers a problem, repairs should be prompt. All staff should be alerted during maintenance and repairs. Identify the work area and notify staff when the work is complete. A log should be kept of problems noted and repairs made. Staff who will be performing maintenance should be trained for maintenance activities. Staff who are not trained for maintenance work are still responsible for reporting problems. While routine maintenance checks are designed to prevent problems from occurring or fix issues early on, failures will still occur. Staff who work with materials and equipment on a daily basis will likely be the first to notice an equipment failure. When a staff reports a problem, do not let it go. Show that you are attentive to maintenance and promptly address the problem. This will encourage staff to note problems in the future. What components should be included in a maintenance checklist? The facility, which includes the greenhouse structure, wiring, plumbing, glazing, and surroundings. Equipment within the greenhouse. Equipment includes environmental systems such as heating, cooling, and the network of environmental sensors. Irrigation systems such as misting equipment for propagation and fertigation equipment. And material handling equipment such as seeders, pot fillers, and transplanters. Deterioration of the greenhouse structure jeopardizes the safety of workers, well-being of the plants, and the environment around the greenhouse by allowing greenhouse chemicals to escape. In order to ensure that structural deterioration does not go unchecked, a facility and structure maintenance checklist should include facility and structure checks. Look for drainage problems. Pooling water is avoided by proper grading around the greenhouse. Landscape plantings should be kept away from drainage systems. Poor drainage may lead to frost heaving in the winter. Ensure that contaminants cannot enter drainage systems. Check sump pumps for proper operation. Inspect electrical wiring systems for corroded parts and faulty insulation. Ensure that outlets are not overloaded with too many plugs on a single power strip. Proper grounding is important in the greenhouse as it is a wet environment. For more information on electric safety, see the Greenhouse Safety Module. Check concrete structures for deterioration. Damage should be promptly repaired and expansion joints sealed. Areas with peeling paint should be scraped and repainted. Paint can be important as a reflective surface or as a barrier against rust. Flaking paint can also be a contaminant. Check for corroding metal. Check for air leaks. Air leaks may be present around vents, fans, and doors. Weather stripping can be used to seal them. Check for holes in the glazing. Lubricate fan shutters so that they do not stay open. A partially open louver may allow several air exchanges per hour. Inspect where pipes enter or exit through the greenhouse walls for leaks. Check for puncture of clay or synthetic liners. Liners are designed to contain liquids which could be environmentally damaging if they escaped. Check the glazing for holes and overall quality by measuring light transmission. Glazing that has degraded over time may reduce light transmission. Plastic film coverings require replacement at regular intervals. For example, Sunmaster infrared anti-condensate thermal greenhouse film has a 4-year lifespan. Consider anti-drip coating and UV coating. Check static pressure of double-layer air-inflated roofs and walls. Either over or under inflation can shorten film longevity. Check for plumbing leaks or breaks and repair promptly. A leak of 1 drop per second loses 113 gallons of water each month. Check for loss of backflow prevention in fertigation systems. Losing backflow prevention can contaminate the water supply with fertilizer chemicals. Secondary containment systems are designed to hold fluids in the event of a leak or spill. Loss of secondary containment system risks environmental contamination if a spill were to occur. The maintenance checklists for environmental control systems include the parts of the greenhouse responsible for maintaining a suitable environment for plants. Sensors should be checked for calibration. Details on sensor calibration can be found in the sensor calibration modules. Actuators, such as motors, pumps, valve solenoids, mixing valves, are the moving parts that trigger control actions and must be maintained. It is a good idea to create a specialized preheating season maintenance checklist. A winter failure of heating equipment could mean the death of plants. A preventative maintenance check prior to using the heating equipment can prevent such a failure. Heaters and boilers should be serviced each year. It is important to service gas burners. Flames on burners should be blue. Yellow tips indicate incomplete combustion, and will cause soot. Unstable flames indicate drafts and possible leaks, allowing damaging gases such as ethylene and carbon monoxide into the greenhouse. The burner manifold and nozzles should be brushed with a bristle brush and cleaned with compressed air. Check gas supply lines for leaks using a soap and water solution. Check spark and pilot for correct operation. Maintain adequate pressure in propane tanks. For oil burners, flame monitoring devices need to be cleaned of soot. Spark should be checked for strong operation. Safety devices should be checked with a test light or multimeter. Horizontal airflow, or HAF, fans should be checked. It is also a good idea to create specialized pre-cooling season maintenance checklists. A failure of cooling during summer may also result in the death of plants. Examine vents, fans, shading systems, and evaporative cooling systems. The maintenance checklist must cover parts of the irrigation and nutrient delivery systems that need maintained. Clean inline filters if necessary. Some filters are self-cleaning, but some are not. For example, the Lakos Twist to Clean has a reverse flushing action handle that, when turned, reverses the flow direction, opens a flushing port, and creates a backwash to clean the filter. A clear filter case lets the operator visually see when the filter needs flushed. Flush fertigation systems as recommended. For example, Netafim recommends a flush with clear water once a month. This will help to remove salt buildup. Sample emitters for proper delivery rate. This can be accomplished by dripping into measuring containers for a set amount of time and comparing the volume. When installing or making line repairs, prevent sand or debris from entering the fertigation system. Ensure that chemicals used are safe for distribution pipes. Some chemicals may damage valves, drippers, flow meters, or other system components. For example, Netafim forbids the use of polyphosphates, red potassium chloride, borax, organic products with a high content of suspended solids, fertilizers with low solubility such as gypsum, and oily chemical products, solvents, petroleum products, or detergents. Lastly, maintain fertilizer injectors. Getting the right concentration is dependent on a properly functioning injector. Know your injector type, Venturi, positive displacement, or membrane type, and perform maintenance as required. For Venturi type, it is essential to maintain pressure and keep the injector clean. Positive displacement is the most accurate and reliable, but make sure that the system is injecting the correct volume. Over time, the membrane in a membrane type can lose flexibility. Systems in the greenhouse involved in the movement or manipulation of plant material, such as seeding, pot filling, or transplanting, are classified as material handling systems. Although all material handling systems will have unique maintenance requirements, many will have an electric motor. Here we will give some examples of generalized electric motor equipment maintenance. The time interval for motor inspection and maintenance will vary depending on the motor type, application, and installation conditions. A general inspection is a check for abnormal wear, vibration, noise, heating, damaged parts, or excessive power draw. The motor should be cleaned. The cables should be checked for good connection, and the mounting connection bolts should be tightened to the proper torque specifications. Specified parts must be lubricated with proper lubricants at the proper time intervals. Motors may or may not have grease fittings, and owner's manuals should direct you accordingly. Shielded bearings without grease fittings must be replaced at the end of the grease service life. Other motors may be oil lubricated, in which case the oil must be drained and replaced. More advanced maintenance requiring the disassembly and assembly of the motor may be required, such as drying the stator winding insulation. Consult your manual and seek qualified personnel. Each piece of equipment will have its own maintenance requirements depending on the device in question. For example, the Javo Standard Potting Machine User's Manual recommends checking the tension of the soil supply belt and elevator chain regularly. Several locations require application of bearing grease every 48 hours of operation. The pot track chain, drill rods, and spindles should be sprayed with evaporation oil monthly. And pneumatic tool oil should be applied to the pneumatic components monthly. Other examples of material handling systems that might be found in the greenhouse, each of which requires their own specialized regular preventative maintenance, includes soil sterilization and handling systems, pot filling machines, transport systems, conveyor belts and rollers, plant container automation, seeders, grading, packing, harvesting machines, and post-harvest equipment such as refrigerators, packaging, and transportation. This list includes many pieces of equipment, but is not exhaustive. The final objective is to determine who should perform maintenance. A responsible and mechanically inclined individual should be available at least part of the time to perform equipment maintenance. In small operations, this may be the grower, but larger operations with 15 or more employees should consider a full-time maintenance employee. A shop with sufficient tools and space should be available. Shop size depends on the size of the equipment and vehicles to be serviced. During the winter, the shop should be heated. Thank you for viewing.